Yes, hello. Is this audible to you? Or Samia, Abia, Fahad, Madiha, Rifat, Sahar, and Zaid. All right. Okay. So now, yesterday in the last class, we had completed till energy density. Energy density we saw the formula and the derivation for. We had seen it for the force between two parallel plate capacitors, the energy density between two parallel plate capacitors. This we have covered. Now, sharing of capacitor. This is also one of the important topics. And Z in your syllabus, cylindrical capacitors and spherical capacitors both are deleted. So no need to do spherical capacitors or cylindrical capacitor for your board exam. In entrances, it will come. Now, sharing of capacitors basically means capacitors or conductors. It is valid for both of it. Like if I take one conductor, this is one conductor and this is another conductor. So what will happen? You have to remember few points. This is, let's say this is conductor 1, this is conductor 2. Sharing of capacitors or conductors means you are connecting them. Both are having initially different potential. Different potentials are there. Now you have connected both the capacitors or both the conductors together. Now the charges will flow from the one having higher potential to the one having lower potential. From the one having higher potential to these charges will flow to the one having lower potential. So let's say this has 4 volt and this has 2 volt. All right, this has 4 volt and this has 2 volt. So what will happen? This conductor number 1 is at higher potential. This conductor 2 is at lower potential. So when I'll connect them with the help of means of wire or anything, when I'll connect both of these conductors, what will happen? From the conductor having the higher potential, the charges will flow to the conductor having lower potential. Now, at till which time both the conductors should be having these charges flow? No, they will flow till the time both the potential becomes equal. Potential in the first conductor becomes equal to the potential in the second conductor. Until and unless this condition is achieved, the charges will keep on flowing from the higher one to the lower one. This is known as sharing of conductors, sharing of capacitors. This is valid for capacitors as well as conductors. Fine. Now see how this will occur if I take the example of 4 volts from the first conductor and 2 volts from the second conductor. It will lose, let's say, some charges and the voltage will become 3 volt. It will gain the charges and the voltage has become 3 volt. Now both the voltages in both the conductors are equal. Now the flow of charges will stop because same voltage has been achieved in both of them. So this is known as sharing of capacitors or sharing of conductors. Even you have normal conductors, no, which you have studied, materials that are conducting. In your lesson, you have in your second term semiconductors. There are semiconductors, you will be studying in detail about the mechanism and the material of conductors, insulators, semiconductors, superconductors, and all these materials. But right now, conductor, you should remember that conductors are materials that allow electrons to pass through them and conduct electricity. So this same principle is applicable for a conductor as well as it is applicable for a capacitor. So sharing of capacitors means this one. Higher potential to lower potential till the time potential becomes equal. This is the basis of it. Now, let's particularly talk about capacitors only now. The principle you people have understood that charges will flow from higher potential to lower potential. Second point is till the time potential becomes equal. But now let's talk about conductors, only capacitors. Let's talk with respect to capacitors only because our main concern is capacitors. Let's say I have a first capacitor whose capacitance is C1 and potential is V1. I have another capacitor whose capacitance is C2, potential is V2. So let's see few terms. This is before sharing. This is the case before sharing. Means right now I haven't connected them. These are independent. No, I haven't connected them. This is the case before sharing. Now, after sharing, what will happen? After sharing means connecting them. So as I have connected them with a single wire, both the capacitors, I have connected them with a single wire. Now I am performing sharing, the same principle that I told you. So this is the case after sharing. This is the case after sharing. This was before sharing, this is after sharing. Now see, after sharing, what will happen? I have told you that charges will stop flowing till when both of them have the same potential. So that's why in this second example, I'm not taking V1 and V2 differently. I'm taking it as a common potential for both of them, which I'm writing it as capital V. This potential is same for both of them because now charges have sharing of conductors and capacitors we have studied right now. So the same principle will be applied on this and potential will become equal to capital V. So potential is same, capacitance will obviously be different. And before sharing, each one was having a different value of capacitance, different value of potential. But before we derive out few things, just mention and let me know a few things. Q1 and U1. This is Q. This will be Q2. So who can tell? Fahad, can you give it a try? What will be Q1? This is your capacitor. Charge on this capacitor. Fahad. Capacitance is C1, potential is V1. So charge on this capacitor should be yes. No, Fahad. Z, you are right. It will be C1 V1. Maria, charge is Q1. You have to tell me the value. That will be C1 V1. No. Q is equal to CV. So charge will be equal to C1 multiplied by V1. Similarly, charge on the second capacitor, this will be equal to C2 V2. Now tell me, C1 is capacitance, V1 is potential. What will be energy? Energy yesterday only we did. All of you write me in the chat box. Keep on answering side by side. C1 we did, V1 we did. Even you people can also try. Sahal and Abia. Okay, Fahad, right? Fahad, please mention whether it is C1, V1, whatever. Just writing C and V won't give you the correct answer for capacitor first. All those who are not able to recall it, look into your notes. Yesterday we did it. 3 formula of energies we did. So which formula included C and V? Just check it in your notes. Yesterday class. In yesterday's class we did it. So yes, Fahad, it will be half CV square. Half CV square. Yes, sir. It will be half CV square. So C is C1, V1 is the potential. So I'll be specifically mentioning it, half C1, V1 square. Similarly, energy for this will become half C2, V2 square. This will be the case. Now, after sharing means now I have connected. Half C1, V1 square. Yes, ma'am. Now tell the charge for this and energy for this Q1 prime, let's say. After we have connected them, this is the capacitance, this is the potential. What should be the charge? C1 capital V. Yes, yes. It will be equal to C1 into capital V because capital V is the potential right now. And in case of energy also, this will be half C1 capital V square. Potential will become the same. Yes. So that's why we are not taking V1 or V2. Right now we will be taking it as V. But C1 and C2 are different. So we have to specify it. So U1 dash and Q1 dash we have written. V C1 plus C2 total charge. No, not the total charge, Maria. Right now, I'm not asking the total charge. This is the total charge which we have to. I'm asking you about the specific one, like Q2. Answer this. Try this, Maria. Only this capacitor, not the total charge. Only this. Okay, yes, it will be C2V. And Abia, can you try the energy now for this one? Energy for this capacitor. Abia? Half C2V square. Square will also come. Yes, correct. It will be half C2V square. All right, so things we have mentioned. So this I have told you, higher potential to lower potential until they acquire the same potential. This you can write down it later. Now, charge before sharing will obviously be equal to the charge after sharing. How? See, if I talk about this, from here, if Q charge is moving out, then Q charge will be entering here. If this Q charge is moving from this conductor to this conductor in this way, then total charge will still be capital Q only. No, it's just that transfer of charge has occurred from conductor 1 to conductor 2. Transfer of charge has occurred, but ultimately charge is conserved. Initially, whichever was the amount of charge, that is still there. If Q, let's say 4 coulomb has flown from first conductor to the second conductor, if first coulomb has 1 coulomb has flown, then obviously some charges will flow. So first write it down. Hello. Okay, see, I was telling you charge before sharing will still be equal to the charge that is after sharing. Like if, let's say, talk about 4 coulombs. 4 coulomb has flown from first conductor to the second conductor. 4 coulomb has flown from this conductor to this conductor. So now 1 coulomb has no charge. One first conductor has no charge drift. Second conductor has 4 coulomb. But total charge is still 4 coulomb. No? So charge after sharing and before sharing both are equal. So what was the charge before sharing? Q1 and Q2. So what will be the charge before sharing? It will be equal to C1 V1 plus C2 V2. This will be equal to C1 V1 plus C2 V2. And what are the charges after sharing? Charges after sharing, Madhya, you had answered that time. C1 plus C2 multiplied by capital V. See, charges after sharing, we have already calculated it. This is the charge that is after being shared, and this is also the charge. So sum of the charges, this will be equal to voltage will be divided equally in charges. No. Voltage won't be divided equally. This is not a condition. Voltages will get divided if everything remains the same. This is not a condition. In any ratio, it can transfer. The condition that when voltages will get equally divided is when the bodies are identical. If the capacitors are identical, means having the same value of capacitance. If the spheres are identical, having the same value of radian, then voltages will get divided. Otherwise, this is not a necessary condition. So C1V plus C2 capital V. This will be equal to what? C1 capital V plus C2 capital V. This is the total charge before sharing. This is the total charge after sharing. So from here, if I take capital V common, what is left? C1 plus C2. And what is the value of capital V that it is coming? Capital V, from here it will be C1 V1 plus C2 V2 divided by C1 plus C2. This is the formula of the capital V that is coming. And what is capital V? Capital V is known as the common potential. We'll do numericals on this because numericals come from this topic. Derivation also come and numericals also come. Find out the common potential. So just this formula will be used. Then we have loss of energy, but I think before calculation of loss of energy, you people complete the writing portion. At least write it till here. Wherever you are getting stuck, ask me. Then we'll do the loss of energy that occurs whenever sharing of capacitors is done. Common potential is this potential. After sharing, I've told you that when two conductors or two capacitors are shared, then both of them will having the charges flown till the time potential becomes equal. And if potential becomes equal means both of them will have the same potential. So the magnitude of that same potential or that common potential, that is given by C1 V1 plus C2 V2 divided by C1 plus C2, this potential. Clear, Fahad? Okay, now let's see the loss of energy that occurs. See, whenever charging is done between, not charging, sorry, this sharing of capacitors is done or sharing of conductors is done, then there is an associated loss of energy as well. So we have to find out that loss of energy. See, energy, that's why we have written energies initially. What will be the change in energy? Change in energy will be, if we subtract both the energies, means initial energy and final energy. And see, since it is a loss in energy, that's why we are writing U initial minus U final. We are not calculating the change in energy. Had we been calculating the change in energy, we would have written U final minus U initial. But right now we are calculating the loss. So obviously this answer will be negative. Now, initial energies that also we had calculated, remember? This is the initial energy. So both of them added together, half C1 V1 square plus half C2 V2 square gives the initial energy. So this gives half C1 V1 square plus half C2 V2 square. This is the initial energy, minus the final energy. See, in final energy, what happened? V became the same for both of them. Half C1 V1 square plus half C2 V2 square. Initial energy, final energy. We are subtracting it. Now see, in this we can at least take capital V common from here. So it will be half C1 V1 square plus half C2 V2 square minus half V square. Here you will be having C1 plus C2 left. Now capital V we have just calculated. Remember, C1 V1 plus C2 V2 divided by C1 plus C2. This is the value of common potential. So we can put this value that we have just calculated in this. So what will be the formula? See, change in energy. A loss in energy will come out to be. This will be half, or just take half here. This will be C1 V1 square plus C2 V2 square divided by 2, this part, minus. Now, instead of capital V, I am writing this term. So, if it is V square, V square will be what? V square will be square of the C1 V1 plus C2 V2 whole square divided by C1 plus C2 whole square. If V is this, then V square will obviously be this. Let's put this value of V square. This will be C1 V1 square, C1 square, C1 V1 whole square. This is C1 V1. This is C1 V1 plus C2 V2 whole square. And in the denominator, you have C1 plus C2 whole square. So this part has been written, V square has been written. In the numerator, what is left? C1 plus C2 is left. And this 2 is also left. Now see, one bracket of C1 plus C2 gets cancelled with this. Now look at the denominators. Here it is 2, here it is 2 multiplied by this bracket. So if you take the LCM will be what? 2 multiplied by C1 plus C2. So it means we have to multiply this term and divide this term by C1 plus C2. The way you take normal LCMs when you have to perform addition and subtraction. C, it will be what? This will be equal to delta U. This will be equal to C1 V1 square multiplied by C1 plus C2 plus C2 V2 square multiplied by C1 plus C2, and the rest of the term will be the same because you already have it in the denominator. This will be C1 V1 plus C2 V2 whole square, and this whole term will now get divided by 2 into C1 plus C2 as we have taken the LCM. So now this derivation also comes in your exam, loss of energy on sharing of capacitors. So it's just that it looks lengthy, but see, calculations are very easy. You have just put in the formula of common potential. The calculations are still easier. See, just open the bracket, just multiply it and open the bracket, multiply this with this, multiply this term with this and this. See, just open up the brackets. Your answers will become easier. This will become C1 square V1 square. It will become C1 C2 V1 square. I'm just opening all the brackets by multiplying it. This becomes C2 square C2 V2 square plus C1 C2 V2 square minus C1 square V1 square plus C2 square V2 not plus, minus. This will become minus C2 square V2 square, and when you open the bracket, this will become minus 2 C1 C2 V1 B2. This is getting divided by what's there in the denominator, C1 plus C2. Yes, C1 V1 will cancel. Okay, yes, exactly. This gets cancelled with this. This also gets cancelled with this. Right. Both these will get cancelled. We'll add it. Now see, if you are able to observe, this is what? This is C1 C2 V1 square plus C1 C2 V2 square minus 2 C1 C2 V1 V2. So just all these four terms have been cancelled. So this becomes what? C1, C2 if you take common. Let's take C2, C1 common from here. See what is left. From here, V1 square is left. C1, C2 has been taken common. What is left from here? V2 square. And from here, if I take C1, C2 common, what is left? Minus 2 V1, V2 divided by 2 into C1 plus C2. Can anyone tell me, is there any algebraic identity formed from here? Are you able to recall any identity, algebraic identities, which you have studied? From here, anyone from the class, anyone?
A square minus B square.
A square minus B square.
A minus B whole square.
Whole square, yes. A minus B whole square, exactly. So this will be C1, C2. A is V1, B is V2. This identity, A minus B whole square. This is equal to what? A square plus B square minus 2AB. From your 8th standard, you must have studied all these identities, algebraic identities. So see, this will become V1 minus V2 whole square divided by 2 into C1 plus C2. So for your calculations, for your numericals, just remember this formula. But for your exams derivation, so this is basically the loss of energy. This is the final loss of energy. But for your exams, from your examination point of view, derivations also come from here. So if derivations come from this portion, then see how to do this. Loss, initial energy, write down the initial energies before sharing. Write down the final energies before sharing. Then when you have connected them, write the difference of initial energy and final energy. You'll reach this step where V is there. So put the values of V as C1 V1 plus C2 V2 by C1 plus C2. When you put the values, take the LCM, open up the brackets, cancel the terms, make it as the algebraic identity, you will get the answer. Yeah, so this looks long, but the calculations are easier. You will understand when you note it down in your notebooks. Try to note it down, check all the calculations, see whether you people are able to understand, and whichever step you're not getting, why this has been cancelled or why is the square of it or anything, or if there is any mistake written in a hurry, just let me know. Ask me and clear everything before we move on to the question of this. So this is the loss of energy that comes when two conductors are shared, or in this case, we are talking about only capacitors, sharing of capacitors. Fourth and fifth step. Uh, which one? This one or this one? Okay, let me name it. This is first, second, third. This is fourth. Now tell me.
The fourth one now.
This one. See, in this, what we did, V's value we have calculated right now. Remember, C1, V1 plus C2, V2 plus by C1 plus C2, common potential we had calculated. So capital V is ultimately, this is the common potential in this. This is the common potential. So V square will be what? If V is this, V square will be simply squaring both the terms, this term as well as this term. So we'll get V square will be equal to C1 V1 plus C2 V2 whole square divided by C1 plus C2 whole square, because we want V square right now since V square is required here. So see, what did we do? C1 V1 square plus C2 V2 square by 2 means I have written this only. Half C1 plus half C1 V1 square plus half C2 V2 square. This can be written like this also. Since denominator is same, we can write it in this way also. Minus half. So 2 is there. V square. Instead of V square, I have written this. C1 plus C2. Now see, C1 plus C2 is there, and here it is C1 plus C2 whole square. So it means C1 plus C2 whole square, one bracket can get cancelled with the numerator 1. So what will be left? C1 V1 plus C2 V2 whole square divided by C1 plus C2 multiplied by 2. Only this step will be left. It's just that we have added it, the value of common potential. Is this clear? And then after putting this, now we just have to open the brackets to solve it. Firstly, we take the LCM because see, in this denominator, 2 is there. In this denominator, 2 into C1 plus C2 is there. So normal taking of LCM, how do you solve LCM? Whatever is missing in the denominator, you multiply and divide it by the same term. Then you get the common denominator. So that's why C1 plus C2 has been multiplied by both of these terms. if the derivation comes from the common potential portion, because many a times in your exams, in your board exams, loss of energy has rarely come in your exam, the derivation, because it is very lengthy. Most of the times, derivation of common potential comes, Samya. Common potential 1V, V is equal to C1, V1 plus C2, V2 by V1, C1 plus C2. That portion comes usually. But in case if this derivation comes, because it can come, it's a part of your syllabus, it can come. So if it comes in your syllabus, then you have to show all these steps till the last step. C1, C2 into V1 minus V2 whole square by C2 into C1 plus C2. Mostly from loss of energy questions come, and derivations usually come from that common potential portion, because loss of energy becomes very lengthy. But it can come, you never know. So be prepared for it as well. It's to a question. Till the time others who have noted it down, you just note down this question. Capacitor of 10 picofarad. This is connected. Capacitor of 10 picofarad. The potential is 20 volt. This is connected to an unidentical uncharged capacitor C2. Calculate common potential. You have to calculate loss of energy on sharing. See, this is C1 given, capacitor of 10 picofarad. That is charged to potential difference 20 volt. C1 is what? C1 is given as 10 picofarad, whose potential is 20 volt. That is connected to an identical but uncharged capacitor C2. Means C2, you don't know. Capacitance C2 has not been given. So it is connected to an identical. If it is identical, then you know the value of C2. Identical means both the capacitance are same. So C2 value is not given directly. It has just said identical. By this, you people should be able to analyze that if C2 is identical, it means it has the same value as C1. So this will also be 10 picofarads. And when it says uncharged, it means potential is 0. So you have all the data C1, V1, C2, V2. Calculate the common potential, calculate the loss of energy. Take 2 to 3 minutes. If anyone gets the answer for the first part, answer. Because first part, all of you should try. Common potential, this is easy. Even loss of energy formula, you have to do. No? You people can just try. Just try. Note down the question first, and whoever gets the answer, start submitting your answer. It's 10 to the power minus 12. 1 picofarad, or whenever you see the word pico, no, 1 picometer, 1 picofarad, 1 picocoulomb, anything. Pico is basically 1 picometer is 10 to the power minus 12 meter. Like you have 1 nanometer is equal to 10 to the power minus 9 meters. In this way. Or you must have heard of 1 angstrom is equal to 10 to the power minus 10 meters. Similarly, pico is 10 to the power minus 12. So obviously to convert it. But Samya, in this question, whenever we use the formula for common potentials, in the numerator also you have the value of capacitance And you have the value of capacitance in the denominator as well. So denominator and numerator units get cancelled. So even if you will convert it, ultimately you will see the 10 to the power minus 12 are getting cancelled. Picofarad from the numerator gets cancelled from the picofarad in the denominator. Yes, answers of the first part, common potential. What is capital V, common potential coming? Only Abia has answered. Abia, just check your calculation once again. Just see once again. I think very slight error you must have done in your calculation. Others also respond. What's the answer for the first part? Common potential, everything I have written it. C1, V1, C2, V2, all these value I have written it. You just have to put in the main formula. Sahal, right? Yes, your answer is right. Sahal, whenever you answer, do mention the units because in your exam, half marks gets cancelled, gets cut for your not writing the SI units. So it will be gold. Okay, so only Sahal has answered it correctly. Abhi has also tried, only these two. Samya, yes, right, correct. Samya's answer is also right. Check the unit that you have written. Magnitude is correct. Madiha again answers that same answer with Abia. Just check once again. Same mistake with that has been done by Abia. I think in the numerator you have not written it. Sid has also answered it correctly. Abia, no. Abia, no. Let's see. Let's discuss it now. Let's discuss it. See, this was the formula for common potential. What is the formula? First one is common potential. This is equal to C1 V1 plus C2 V2 divided by C1 plus C2. Now values, if you put C1 is what? 10 picofarad multiplied by 20. Fine. Plus C2 is 20 volt. Right now I'm not converting. Let's see. C2 is 10 picofarad multiplied by 0 divided by C1 plus C2 10 picofarad plus 10 picofarad. See, P is equal to what? 10 picofarad into 20 volt. This gives 200 volt into picofarad. This is 0 divided by 10 picofarad plus 10 picofarad gives 20 picofarad. Picofarad gets cancelled. 200 divided by 20. 0 gets cancelled. Answer is 10. 10 volt is the right answer. What was the mistake done? Both of you, Madiha and Abia, in the calculation portion or in the formula?
Oh no, ma'am, I actually multiplied. I didn't add. I did C1 V1 into C2.
Okay. C1 V1 into C2 V2. Fine. And what about you, Abia?
I made a mistake in the formula.
Formula. Fine. Now, in the second part says what? Second part says the calculation of energy. So, energy will be what? Loss of energy we have calculated. It was C1 C2 V1 minus V2 whole square divided by 2 into C1 plus C2. This was the formula. Now, if you put everything, let's just convert it right now, because right now we have to require the units. C is 10 picofarad, means 10 into 10 to the power minus 12 farad. That gives 10 to the power minus 11 farad. So 10 to the power minus 11 into 10 to the power minus 11. V1 was what? V1 minus V2 whole square is there. V1 was how much? 20. Okay, V1 was 20. So 20 minus 0 whole square divided by 2 into 10 to the power minus 11 plus 10 to the power minus 11 plus 10 to the power minus 11. This is your formula. So this becomes what? 10 to the power minus 22 into 20 square becomes 400 divided by, this becomes 2 into 2 is there, and 10 into the 10 to the power minus 11 plus 10 to the power minus 11 can be written as 2 into 10 to the power minus 11. So what's your answer? Final answer. 2 gives 200. This 2 gives 100. So 10 to the power minus 11 and 10 to the power 2, that gives 10 to the power minus 9 joules. This much of energy has been lost. All right, so all those who haven't written it, note down it. See, if you add anything 2 times, you can write it as 2 into 10 to the power that. Like if I ask you 4 plus 4, this gives you 8. You can write it in this way also, 2 into 4, 2 times 4. That will also give you 8. So anything that gets added, it's by itself twice. So we can write it 2 into 10 to the power anything. So here it was 10 to the power minus 11 plus 10 to the power minus 11. Okay. Done. SI unit of energy. Yes, yes, it's Joule. SI unit of energy, that's Joule. And CGS unit is erg. Since it's energy only, no, loss of energy is something we are just naming it as loss of energy. But ultimately, it's the energy. This question. Okay, this is very important. See, this comes in your theoretical questions. This you people are aware of. If you have what? If you have a parallel plate capacitor which is connected to a cell whose potential difference is V naught, air is filled, area is A, separation between them is G. See, this part is very important because in most of the theory questions in previous you will find this. 4 things we'll discuss: capacitance, charge, potential difference, electric field. If air is completely filled, then remember the formula was epsilon naught A divided by D. Charge Q naught. Q naught was equal to C naught V naught. If capacitance is C naught, potential is V naught, then charge will be equal to what? C naught V naught. Potential difference is V naught. And electric field. Electric field from this relation that we did, dV by dr. This is one formula for all those who are not aware of. If you write just the magnitude of electric field, that is equal to potential divided by distance, and potential divided by distance, this quantity, it is known as potential gradient. This is known as potential gradient. So these are the 4 things you know. Now 2 cases we'll study. If the battery gets connected, if the battery gets disconnected when dielectric medium is introduced. So like this, dielectric medium has been introduced. Now battery remains connected. This is our first case to study. Case 1 is battery remains connected. What all will happen? See, when a dielectric medium has been introduced, dielectric constant gets multiplied. So it will become what? K epsilon naught A by D. Now C naught was the initial capacitance. K is getting multiplied to it. So obviously capacitance is getting increased because it is getting multiplied by a quantity. So capacitance increases when battery remains connected. We haven't disconnected the battery right now. Now regarding the charge is CV. So if capacitance increases, then obviously charge will also get increased because it is K times C naught V naught. So charge also increases. Remember, this is very important. When the battery remains connected, potential remains constant. There is no effect on potential. This is from your theoretical questions. And if any numerical comes and there's a usage of battery connection or disconnection and all this, then you can use this theory portion. So V is what? V naught. That remains constant. The same. Potential difference remains the same. And electric field is what? Electric field is V naught divided by D. So if this remains constant, then obviously electric field also remains constant. So four things: capacitance increases, charge increases, potential difference and electric field, both of them remains the same. Now see, if the battery gets disconnected, we have disconnected the battery, what all changes will occur? Since the material is dielectric, so it will still be Kc naught, means capacitance will still increase. This is the important point when the battery gets disconnected. Charge remains constant. Always remember this. Potential remains constant in case of battery getting connected. If the battery gets disconnected, then your charge remain constant. Don't increase or decrease the charge. Whatever is the value of charge, that will still be the same. Charge's value remains constant. But in case of potential, what happens? Potential is written as Q naught divided by C naught. You know, C is equal to Q by V. So V will be equal to Q by C. So V naught will be equal to Q naught divided by C naught. And since C naught is actually equal to K times, capacitance becomes K times C naught. So potential also decreases. And if potential decreases, therefore your electric field also gets decreased. So these are the points that you have to remember. Capacitance increases in both the cases. From the original one, air one, capacitance increases in both the cases, battery connected, disconnected. Potential remains same in battery connected, potential decreases in battery getting disconnected. Charge remains same in battery getting disconnected, but charge increases in battery getting connected. Electric field happens, whatever happens to potential. So these are very important points, and I will suggest you people to note these down first before moving on to anything. From here, start noting from here. I'll scroll it slowly. But do make it a point whenever you are revising these points. From your entrance point of view, your competitive exams, from your board points of view, all these are important. K naught in what? In capacitance? Which one you're asking? In anywhere? No, that depends. Like in case of capacitance, we have studied that it becomes like C naught V naught. See, in case of charge you have CV. Capacitance becomes K times. If you multiply anything, that will get increased. So obviously, capacitance increases in the first case. Here, capacitance increases because it is getting multiplied by K. Now, charge, what happens to charge? Charge gets multiplied by CV. So C is now K times. So again, your charge is also increasing by K amount. Let's say initially it was 6 coulomb. K's value is 3. So now your charge will become 18. So it is increasing 3 times. So whatever value will be the K, it will increase. But this is not valid if battery is disconnected. The next case. Clear, Fahad? Any other doubt? This can come in MCQ. This has come actually. Fahad, in your entrances, in your previous MCQs or in your previous year papers, MCQs, these questions have come. That's why I was emphasizing so much to note down all these things, and this is important and mark it as important. And do not forget to revise it whenever you are studying this lesson, because it is not only helpful for here this chapter, for current electricity also it can be helpful. But for this chapter, it is definitely helpful. Just write done when you have completed it. In this fourth formula, no, I was just telling that V naught divided by K is the new potential now. So that's why electric field is also getting decreased. Nothing. You can just erase it. It has no significance. All right. Now see, last portion of this lesson is left, which is your circuits. So circuits we have to practice, and obviously in the next class, your next class is tomorrow. So we'll be practicing circuits in tomorrow's class only. But right now, let me just tell you something that will help us in understanding the circuits in the next class. Only circuits is left. Just understand one thing. This is important. Whenever you see a single branch, your charge, and please understand this carefully, because you have circuits in your capacitors, you have circuits in your current electricity where resistors are connected, then you have in your AC lesson, you have inductors connected, and then in AC also you have all the inductors, capacitors, resistors connected together. So the basic or the basis for all these division of charges, current, potential remains the same. So it's better if you understand this part. So right now only I'm just telling you this in brief, then I'll end the class. Remember, unless and until you see a branching like this, any branching in this form, branching means branching of wire. Like this was a straight wire coming, now it has been branched into two different wires. Here you will be having what? Here you will be having the current in current electricity, but right now let's talk about only charge. Charge gets divided on branches. Even if it's a capacitor in between, charges will be the same in the same wire. If you bend the wire like this, still the charge will be the same. But as soon as you see a branching, charge gets divided. This is opposite when we study potential. In case of voltages, like this, in this example, this was first capacitor, this was second capacitor. In this, what is happening? In this, when the current is moving from here, when the current is, not the current, the charge is flowing. A capacitor came, the charge remained the same. Then again, a capacitor came, the charge remained the same. So all the capacitors are there, the charges are remaining the same. As soon as the branching occurred, charge got divided. And it doesn't matter that the charge is getting divided into equal portion. This is not the condition. Charges can divide into any ratio. How they, when they will be divided equally, that we'll all see everything. But right now, remember, this will get divided. Now see, this is the same wire. So the charge in this branch is same. Similarly, the charge in this branch is the same. So I'll give you time to note down all these things in the next class, but you should have a brief idea of it. Just opposite to it is the case of potential. In case of potential, you have a single wire, potential will be the same. You branch the wire. Branching doesn't affect your potential. It will still be the same. But as soon as a barrier came, like a capacitor or a device like resistors, potential changes. If it is VA at this side, it will become VB at this side. So potential changes because of capacitance. Yes, you have to divide the charge, Fahad. Whenever branching comes, you have to divide the charge. charge in case of capacitors and current in case of resistors whenever branching will come, and that will only help us decide series and parallel combination, because many a times just by looking at the circuit we are not able to identify whether it is series or parallel. So keep this in mind. I'll revise this once again in the class tomorrow. I'll give